So it's a very, very simple, basic ED model. Somebody comes through, gets seen at reception, goes to sit and wait in the waiting area. A nurse will come and get them and take them to triage, and then take them over to an exam room where a doctor goes and visits. The nurse will have a chat with the doctor, and they might decide to go to a CT or X-ray or other type of examination, and then the doctor decides what to do, and the patient leaves or gets treated and then leaves. But we'll run a model and see how we get on. It's 4. It's right. So as somebody, there's other things happening as well. By the way, you'll see the receptionist going to the telephone or whatever. That's basically there just to get in the way of the normal process. Because if the telephone runs too often, then the patients don't get seen. So the patient's being spoken to by the reception at the moment, and then she's registering, goes and sits down. Okay, sorry, gets taken by the triage nurse to the triage, and has a chat down here. And then once they're finished that, there's another nurse having a chat with somebody as well. Then the nurse takes the patient over to the bed. Doctor goes and has a chat with the patient. I think after that, there's other stuff as you see. I think then the nurse has a chat with the doctor to figure out what they're going to do, and they carry on the process. In the mechanics and the logic of it, you've got the process flow. So basically, patients arrive. This is basically a process flow that you would normally have anyway. They wait in line, they get acquired by, they acquire the location, which is, in that particular case, is the registration area. They need some staff, then they walk to the registration, they have a chat, then it goes into the next area down here, which is the triage. So they acquire a triage seat in this case. If there isn't one, then the patient just goes to the waiting room and waits. Same as you would get in normal reality, where if something's not available, then nothing happens until it is available. And also, because if there's a staff member that's required, if they're standing away over the other side of the model, then you also have to add the time it takes for them to walk from where they are to where they need to be. So it's not just a matter of bang, we've got a staff member and it takes 5 minutes. There's a lot more involved in the basis than that is there. Is that the kind of stuff you're looking at the moment, Gary?
Yes, that's excellent.
Okay, mate, I'll keep on going. So then there's the next section is the triage, where it just says escort then process, which is that's the bit we just talked about. There's a couple of areas. If there's no room, then they go down one route. If there is space, then they go down another one and wait for all the different resources to become available. Then they get sent down to the bed, where they acquire the same staff nurse. Usually, it's the same nurse. Actually, there is an option to say use the same person or not if they don't care, and then they carry on down here. This is basically just very simple logic to say get a bed and take them there, and then the MD has a chat with them, and then the two have a chat. They go and the logic splits up. One is to go and acquire the nurse, and the other one is to acquire the doctor. And once you've got both of them, then they can join together and have a chat about it, whatever they talk about. Simulation is really just a matter of retaining time and resources. So we don't really care what they talk about. We just know that they have to sit there for a little bit to have a chat. Once they've done their discussion, the decision is made, and you can see here that they can either go, in this particular model, there's all sorts of, it's variable as much as you want. This particular ED, you can go to labs, X-ray, EKG, sutures, or departure, depending on what's wrong, depending on the patient track. Same process here. It just goes down, it acquires the location that they're supposed to go to. If it's available, then they can get taken there, and they might need a staff member to take them there. Then the process is done, and then the patient in the X-ray case is escorted back to the room. Then they release the radiographer, release the X-ray, and then the doctor has a chat about it, figures out what to do, may well treat them, may well not, and then sends them on the way. So it really, the simplicity of the process is obvious. The complexity is when you have when you've got multiple projects, multiple patients, multiple tracks, various different things, but all with competing resources. So that's basically just the one concept of the model. Now, where it gets more interesting in terms of this stuff is waiting area. Gary, you talked about waiting area. That is there enough here? That's fine. You've got how many seats here? Well, it looks like 9 seats. Fine if you get 9 patients, but then the chances are they've got people that come with them, particularly if they're children. So you might find that for every 1 patient, there's 4 seats required. And these people might stay there until the patient is taken somewhere else. So you get, this can come up a little bit as well. You also have the option when somebody turns up that needs emergency treatment, then what do you do? Then quite often, well, depending on how you set it up, specific emergency staff, doctors will drop everything they're doing and run to the door and pick up the person and go and do what they need to do. So it's not just a matter of a process. There's processes with logic, with gates, with decision points, all this kind of stuff as you go through, just like you would have in a more complex flowchart. That's pretty much the basis of what we're talking about. Now, Gary, the specifics I know that you're interested in. What do you want me to cover? Oh, the experiments, of course. I'll just go into the experiments and then you can tell me what else you want to talk about. So this is one scenario. The one scenario could be the layout, the number of staff, how busy the staff are, how many patients there are, what type of patients. These are all built up to be one scenario. I'll just do them down here. This is an experiment that we've already run, so we don't need to run it again. So in this particular one, there are 4 different scenarios, and things were varying. There's a number of exam tables, the number of MDs, and the number of RNs, and there's just different numbers or whatever. And what we do is we run the same model with the availability of these different staff members and resources. When we run it, we actually run multiple versions of the same scenario, in this case 30 versions, because sometimes a person might take, it's just basically every time is a statistical distribution. So you have to run it multiple times to give one answer. So there's 4 different things we run, and then you look at the results. Oh, I haven't run this job. It must be an old one. Okay, I'll quickly run it. You can see that they're mode running actually 8 projects at any one, 8 jobs at any one, 8 simulations at any one time. Now that's us coming to the end. You can see how they're gradually working through. Once it's done, you can go, right, we're done. Let's view the results. And here we are. So every one of these dots is one of the scenarios that we've run, and you can see it's running across 4 different scenarios. The box plot here just shows you the mean and the minimum and the average, etc. 25 percentiles. You can tell here because the average length of stay, therefore big is bad. So scenario number 2 is obviously the one that gave you the best throughput of patients as we go. Dashboards of statistics, that's the length of stay in each of the areas that they were in. Table, this is basically an audit table of an audit list of everything that's happened. Person states how this is at each individual person, how long they've been in transit, how long they've been waiting in line, what they've been receiving time, and how much percentage of utilization each of the people have been put through. Oh, the amount of statistics you can get is just crazy. You just need to figure out which ones are appropriate to what you've got. The scenarios that we did, this is the length of stay that we had for each of the scenarios that we ran. And no, we don't have any more information on that. Do we have anything in the dashboards? No, let's run that. Let's run and we'll see if something pops up. There you go. Live data capturing of the milestone times, the treatment start, treatment finished by the different patient tracks, PCIs. You do PCIs, the patient tracks, patient pathways?
I have no idea.
Okay, so that's the different types of patients.
Yep.
So you can run multiple types of patients as you go through. Experiment dashboard we've seen already, and this is things like average length of stay, the state of each of the staff in transit maintenance. Maintenance. I don't know where the maintenance would come in. Idle, how long they've been answering a phone for, how long they've been idle, how long they've been working for, and how long they've just been walking around. Now you mentioned that there's multiple levels in the facility you're looking to build.
Yeah, in the new hospital, there's multiple levels in the new ED.
So that in transit would be very, very relevant to what you have, because it shows how long people have actually, staff have been walking around, not actually doing anything other than just walking around with people. Obviously, the closer everything is, the less transit there is, then the more efficient their time is. And I can't get any further down. See if I can pull that one up. What's this one? Waiting room, location, throughput. So yeah, that's the different types. You can see there, PC2 doesn't actually go to a waiting room. They go straight to the exam room, because they must be emergency patients. That's pretty much it in terms of the milestones there, the dashboards that we've got up and running. Yeah, any more would be not a waste, but it would just be repeating ourselves.
Yep.
Yeah. The only other thing, actually, come to think of it, worthwhile pointing out, is the staff can have timetables, so they're often on shifts. Staff have got skill levels, so you might need to go and find some ask for help every now and again from a more experienced person, and they've got wages. So you can actually figure, as do the CT scans and all the different resources. So you can actually do a financial model as well. So anything else you want to ask about?
That's excellent.
Right.
No, I think that's sufficient. If you can just whiz it up into a movie,
Yep, I'll do.
That'll be great. And I'll shoot it round to the relevant people and at least start the conversation.